Okay, Max. I'm teaching now, so you need to be quiet. All right, how's it going, everybody?
Doing well. How about you?
Pretty good.
Oh, not bad. You guys can see the problem up on the screen?
Yep, you can see it.
Perfect.
Yep.
All right. Cool. We'll give everybody a couple more minutes. We got 77 of the 100 and, I don't know, 15 of you that there should be. So we'll give it a couple minutes and see if a few more people show up before we get started on the actual problems. But first thing is I sent out just a couple minutes ago a new link to the sheet to use on the test. Delphine had noted a couple of little mistakes I'd made, so I corrected those, took down the old one, and put up a new one. So if you've printed off the old one, make sure you go back through. It was in the trapezoidal and the right Riemann sum approximations that I made corrections. So reprint that page and throw out the old one. And if anybody else sees anything else that I might have made a typo on, just let me know and I'll fix it and put it back up. But I think it should hopefully be good now. Hopefully that'll be helpful. Have you guys had a chance to look over it yet? I guess not. All right. You guys can hear me or no?
Yep, loud and clear.
All right, perfect. Okay. All right, well, make sure you look over that sheet because just having it in front of you on the test won't be, I mean, it'll be helpful, but it won't be as helpful as if you've already read through it and sort of know those things and can just reference it to make sure you haven't screwed something simple up that you should know. So look through it, make sure you know it all, and then use it as a reference if you need it. All right. Let's get started with this first problem. So we've got a table here that's giving us the rate at which water is leaking from a container, which we can model using a function that's twice differentiable, which is R. So R is measured in gallons per hour, that's the rate, and T is measured in hours from 0 to 1. The values of R of T are in our table as for T. So we want to use the data in the table to find an approximation for the derivative of R at 0.5. So the derivative of R, the best way we can approximate that from a table is by using an average rate of change on the smallest interval that surrounds 0.5. So from 1/3 to 2/3. And so we'll approximate R prime of 0.5 as 5 minus 8 over 2/3 minus 1/3. So that should be -3 over 1/3 or -9 gallons per hour, or gallons per hour squared. Any questions on that one? Everybody's good there? RFA, I'm not using the mean value theorem at all. We are approximating the derivative using the average rate of change because we don't have an actual function to use. So if I was using the mean value theorem, then yes, I would have to verify the conditions, but that's not what we're doing here. We're approximating the instantaneous rate of change using the average rate of change, or the slope on the interval. Any other questions there? All right. So part B, we're going to use a left Riemann sum with 3 subintervals from the table to approximate the integral from 0 to 1 of R. So using the left Riemann sum, these are all equal subintervals. So we can put just the length of each subinterval out in front, which is 1/3. And then using the left endpoints, that'll be 11 plus 8 plus 5. So that's our integral from 0 to 1 of R is approximately equal to 1/3 of 11 plus 8 plus 5, which is, I think that comes out to be 8. And if we are integrating a rate function that is gallons per hour, we should get 8 gallons. So if it were to ask us what that means in the context of the problem, we'd be saying that that means that 8 gallons of water had leaked out in that first hour from the tank. Any questions on that part? Okay. This is a left Riemann sum. If we were told that this function was strictly decreasing, it looks like it's decreasing, but we can't be guaranteed that it's always decreasing because there are, there's stuff going on between 0 and 1/3. It might have gone up from 11 to 15 and then down to 8. But if we knew that it was strictly decreasing for this left Riemann sum, then we would know that our approximation was an over approximation. It doesn't ask us about that, but if we knew that it was strictly decreasing, it would be an over approximation. No, Catherine, it's 1/3 because the length of each interval is 1/3 of a unit. 0 to 1/3, 1/3 to 2/3, and 2/3 to 1. Not 1/4 because there's 4 values there, but 1/3 because the length of each subinterval is 1/3. Does that make sense? Okay. All right. Any other questions there on B or A? All right, let's look at part C. So part C says use the data in the table to evaluate the integral from 0 to 1/3 of R prime. So the integral from 0 to 1/3 of R prime should just be, there we go, should just be capital R, which is the integral of R prime, evaluated from 1/3, from 0 to 1/3. And so from our chart, R of 1/3 was 8 and R of 0 was 11. So this should just be 8 minus 11 or -3. Write out this stuff here. Any questions there on part C? For integrating R prime, we're getting R values. So our R values, R of t is measured in gallons per hour, so that'd be gallons per hour.
Do you need to write the units if it doesn't ask?
I'm not sure who was just talking, but whoever that was, I couldn't hear you at all. It's way too soft.
I think she asked if whether we should put the units for this problem.
Oh, no, it doesn't specify that you need units, so you don't need to put units for it. Was that you, Molly, that was asking? Yeah, okay. I'm not sure. Is that better again? Okay. So now it's too far down in the chat. Somebody asked if part A, I think it was Jordan, asked if part A asked for units. So no, it didn't ask for units. So we didn't need to put negative 9 gallons per hour squared. But if we did, that would have been, if it did ask for units, that's what they should have been. But part B did ask for units. So we want to make sure we have them there. Everybody good with A, B, and C so far? All right, so for part D, they are now giving us a summation notation using a right Riemann sum. And it tells us that the limit of this sum can be interpreted as a definite integral. And we want to be able to write this limit as a definite integral. And so we've kind of got to go through the steps that we normally would use backwards, because normally we turn the integral into the limit notation. So we know that the 1/2n over there should be our delta, normally what's our delta x value, but in this case it's our delta t value, since our variable in here is t for this problem. And so 1/2n should equal delta t, which is always equal to b minus a over n. So that shows us that b minus a is equal to 1/2, which tells us that the length of the entire interval is 1/2. So when we write out our integral, the distance from a to b, or the length from a to b, should just be 1/2 a unit. And then we know from what's inside of our function here, r of 1/4 plus k over 2n, that's always equal to a plus k times delta x, or in this case it's delta t. And so our a value, our starting value, should be 1/4. So if our starting value is 1/4 and the length of the interval is 1/2, we should go from 1/4 to 3/4, and this is an integral of r of t dt. Any questions on that one? Shayla, the 3/4 comes from, we found that the length of the interval needs to be 1/2, and we know that the a value is 1/4 from the formula of, this is f of, or in this case r of a plus k delta t. So the a is 1/4, the a is 1/4, and then the length of the interval from a to b is 1/2, so 1/4 plus 1/2 gives us 3/4. Sean, yeah, I wouldn't be surprised if they put one of these on there. Nick, you're asking, where does the k come from again in the summation? So remember let me put in a new page here. The normal notation is that an integral can be expressed as a limit, as the limit as n approaches infinity of the sum from k equals 1 to n of f of x sub k times delta x, where x sub k is just the, or k, any k value is just the subinterval, which subinterval number you're at. So we're summing together the heights. This is the height of each of the rectangles, and this is the width of each of the rectangles. And we're summing together all of those areas to get the entire area underneath the curve. K is just an arbitrary representation for which subinterval you're on. We're on k equals 1, or we're on k equals 2, or we're on k equals 3, or we're on k equals k, the arbitrary kth subinterval. Does that make sense, Nick? Okay. Vaishnavi is, do we have to show all the steps of identifying A, B, and delta K? I mean, the more work you show, the better. I think if you wrote what I wrote on the right here, 1 over 2n equals delta t equals b minus a over n, b minus a equals a half, and then you just, from here, you could just say that a equals 1/4 from this. Maybe putting this up here too would be nice, but I mean, you need to show at least what I showed, I think. You don't need to show any more than what I showed, but at a minimum, this would be good. Any other questions on this problem?
Can you hear me better now, or is it still quiet?
It's still pretty quiet, but I can hear you at least.
Okay, so for part C, do you need to expand it into the r of 1/3 minus r over 0, or minus r of 0? Can you just leave it as it was?
This right here, and part C?
Yeah.
Yeah, I mean, it needs to be written as r of 1/3 minus r of 0. I mean, you could have just gone from that it's r from 0 to 1/3 equals 8 minus 11, which is -3. You didn't need to write this piece down here if you didn't want to.
Okay.
Any other questions there? Okay, so this next problem that we're going to take a look at is the only practice problem that the College Board put up that's supposed to be representative of the 25-minute question that they're giving you this year that's different than normal. So I sent this one out to you guys a few minutes ago, maybe an hour or so ago, in the hopes that you might have a chance to look at it. It's a little bit weird. I mean, the first 2 parts, A and B, deal with this velocity function, but then the rest of it moves on to something completely different. So really, it's just kind of like, it looks like what they're going to do is just sort of give you a jumble of different things and call it one question. So I think all the free response stuff we've been doing is still plenty good enough. There's nothing new per se about their new 25-minute question. It's just pieces of other questions sort of stuck together as one. So let's take a look here. We've got the velocity of a particle that's moving along the x-axis, and that's v sub p of t. And they're giving us the units for all of that and telling us that it's at the origin at the beginning at t equals 0. And then we want to justify why there must be at least one time t on the interval 0.3 to 2.8, for which v prime sub p of t, which is the acceleration, equals 0. So this is a mean value theorem for derivatives question, or even more specifically, we could say it's Rolle's theorem. So the mean value theorem says that if a function is continuous on the closed interval, which it is, because it says that this function is differentiable, and if a function is differentiable, that means that it's continuous. And then it also has to be differentiable on the open interval, which it says that it is. It's a differentiable function. Then there's at least some point, no, I shouldn't have written f there, where v sub p prime of c, some value along here, is equal to the average rate of change on this interval. So that would be 55 minus 55 over 2.8 minus 0.3. And so our acceleration v prime needs to equal 0 somewhere by the mean value theorem. Or you could say, or by Rolle's theorem, which is just the specific case of the mean value theorem in which f of b and f of a are equal to each other. Everybody good there? Any questions on that?
Okay, this is kind of, I looked at it as intermediate value theorem.
It's not the intermediate value theorem.
Can you not do that? Because like the graph of v of t goes from 55 to negative 29, so it has to cross the, like it has to hit 0 at some point. And then
No, that's not correct at all, because we're specifically asking about the derivative of it. And the intermediate value theorem doesn't deal with the derivative of it at all.
right, but I said if velocity was 0, then acceleration is 0.
And if velocity is 0, acceleration is not necessarily 0. That's not true.
Okay.
Derek, what would happen if you mentioned both? You mean both MVT and Rolle's theorem, or mean value? Yeah, if you said mean value theorem and Rolle's theorem, then that's fine. Yeah. So Sean, what do you mean? So that part state the interval? Yeah, I mean, we want to say that V is continuous and differentiable on our interval. You do need to say that, which I got V sub P is continuous and differentiable. I should have said, you know, it's continuous on the closed interval and it's differentiable on the open interval from 0.3 to 2.8. Let me scroll back up a little here. I missed some people's questions because a lot of people are typing stuff. Yes, Achuth, you would need to mention the specific theorem. You have to specifically say mean value theorem or Rolle's theorem, or else they won't give you the points for it. Natalie, MVT has to D when average rate of change equals in.
I think it has to do with.
Has to do with. Yes, the mean value theorem says that if a function is continuous on the closed interval and differentiable on the open interval, then the average rate of change is equal to the instantaneous rate of change at some point on that interval. Yeah. Yeah, Delphine, I think if you write MVT, that's fine. I mean, it doesn't hurt to write it out, but I think they'll know what you're talking about. Most people just abbreviate it in math in general. Let's see, Jordan is saying that the average rate of change is negative from 0.3 to 1.7, and the average rate of change is positive from 1.7 to 2.8. Enough to say that there is a point where the derivative is 0. Yeah, I mean, you could say that somewhere between 0.3 and 2.8, there must be a local minimum, but the justification for why that's true is still the mean value theorem. So you still need to state that that's true because of the mean value theorem. That's the base part of the mean value theorem. You just kind of stated it in a longer way. Melinda, yeah, you need to say that it's continuous on the closed interval and differentiable on the interval. That's part of your justification. Any other questions there on part A? Yes, Derek, it has to be that it's closed. It's continuous on the closed interval and differentiable on the open interval. That's the specific criteria for the mean value theorem. Yeah, I mean, if you just said the stated interval, you could. That's fine. All right. Any other questions there on A? All right, so part B, we want to use a trapezoidal sum with 3 subintervals to approximate the value of the integral from 0 to 2.8 of V. So our integral from 0 to 2.8 with the trapezoidal sum since these subintervals are not equal, we just need to find the area of each piece of it. And so the part from 0 to 0.3 has a length of 0.3. And then we've got base 1, which is 0, plus base 2, which is 55, divided by 2. And then we've got the next one, which is 0.3 to 1.7, so that's 1.4 is the length of that subinterval. That one's 55 plus negative 29 divided by 2. And then the last one is the difference between 2.8 and 1.7, which is 1.1. And that one's negative 29 plus 55, also over 2. And whatever that comes out to be is an acceptable answer. And since you're not required to simplify numeric answers, this answer right here is good enough. You could just leave it just like that. Any questions on part B? All right, let's take a look at part C. So part C totally disregards everything from part A and B, has nothing to do with it. Gives us this new graph. It's a graph of F. Gives us some information about it, that we've got a couple of line segments and a quarter circle, and that there's a specific point 3, 3 minus root 5 on the graph. And it asks us to find the value of the integral from -6 to -2 of F in part C, given that the integral from -6 to 5 is equal to 7. So for this first part here, we need to remember some of our rules. The integral from -6 to 5 of f of x dx should be equal to the integral we're looking for, which is the integral from -6 to -2 of f of x dx, plus the integral from -2 to 5 of f of x dx. And since we know that this first piece here is 7, we can say that 7 minus the integral from -2 to 5 of f of x dx is equal to the integral we are looking for, which is the integral from -6 to -2 of f of x dx. Everybody okay with that first part, with that setup there?
Yes.
Okay. So from there, what we have to do is we have to find the integral from -2 to 5. So in order to figure that out, we need to use our graph. So we've got 7 minus, and then we'll do each piece of this sort of separately. The piece from -2 to -1, that's a triangular piece, 1/2 base times height. So that's 1 times 1 divided by 2. That's a half. And it's above the x-axis, so it's positive. And then this next triangular piece right here, since we know this is a line segment, the slope of this line here is 2. So if I've gone up 2 over 1, when I go up 1, I've gone over a half. So the base here is 3 halves, 1 1/2. 3 halves times 1 is 3 halves, divided by 2 is 3/4. But since it's below the x-axis, that's a -3/4. Then we'll look at this next triangular piece, which has a base of 3 halves and a height of 3. 3 times 3 halves is 9 halves, and divide that by 2. That piece should be a positive 9/4. And then we've got this quarter circle piece that we've got to deal with. So we need to find just this area in green. And to find the area in green, we'll have to use this entire area of this square and subtract the quarter circle piece. So we've got the whole thing is 9 for the entire square, 3 by 3. But we need to subtract from that the area of a quarter of a circle that has a radius of 3. So that should be 1/4 pi times our radius squared. If our radius is 3, that's 9 pi over 4. So 9 minus 9 pi over 4. Any issues with that? Other than I didn't put my bracket to end it. That answer is an acceptable answer because you don't need to simplify numeric answers on your AP test. But if you desperately want to, 1/2 minus 3/4 is -1/4 plus 9/4 is 8/4. That's 2. So we got 2 plus 9 is 11 minus 9 pi over 4. So if we have 11 minus 9, 7 minus 11 minus 9 pi over 4 gives us a positive 9 pi over 4 and minus 4. Let's see here. Dana, how did I get the -3/4? The -3/4 is, I'm going to color it in here in purple. It's the area of this triangle. It's negative because it's below the x-axis, and it had a base of 1.5 or 3/2 and a height of 1. So 3/2 times 1 is 3/2, and then since it's a triangle, it's 1/2 base times height, so half of 3/2 is 3/4. Does that make sense, Dana? Okay, let's see. Next here, Chun. How did I know that it is the interval from -2 to -6? I didn't do any interval from -2 to -6. Chun, I did an interval from -6 to -2, which is what I'm looking for. It says find the value of -6 to -2. So I knew that the interval from -6 to -2 should be the interval from -6 to 5 minus the part from -2 to 5. And I'm not sure about your question, Chen. Natalie, the 7 came from right here. It said that -7 to 5, that integral is 7. It gave us that. And so -6 to 5 should be -6 to -2 plus -2 to 5. And so we just replaced the -6 to 5 part with a 7. Does that make sense, Natalie? Okay. Chen, I'm still not sure what you're asking. Maybe, I don't know what you're asking me, Chen. When I'm subtracting the integrals, how do I know it's -6 to -2? Oh, well, I mean, I just chose to break it up into -6 to -2 and -2 to 5 because, for one, -6 to -2 is the piece I'm supposed to be looking for, and -2 to 5 is the only part I can find because that's what my graph encompasses. So, all right. Any other questions there on part C? Why would I have to switch the 5 and the -2, Chen? There's no reason to do that. From -6 to -2 and -2 to 5 encompasses everything from -6 to 5. And going from -2 to 5 is going from left to right. So that's the way it should be. I shouldn't flip it. All right, for part D, we're looking for the integral from 3 to 5 of 2f prime of x plus 4. So the integral of 2f prime of x plus 4 should be 2f of x plus 4x evaluated from 3 to 5. So this should be 2 times f of 5 plus 20 minus 2 times f of 3 plus 12. Make sure you get that whole second part in parentheses. So f of 5, let's see, on our graph, f of 5 is 0. So 2 times 0 is 0 plus 20 minus 2 times f of 3. In Darius, we find f of 3 because it tells us it is known that the point 3 comma 3 minus root 5 is there. So that's 2f of 3. And then what did I have there? Plus 12 inside those parentheses. And once again, you don't have to simplify. Once you get it down to a numeric answer, you can't leave it like this with the f of 3 and the f of 5. But once you get it down to this, you can leave it like that if you want. Or you don't have to if you don't want to. You can simplify it. So you get 20 minus 6, and then minus 12. So 20 minus 18 is 2. And then we got minus 2 times negative root 5, which is plus 2 root 5. But like I said, if you want to just leave it as this 0 plus 20 minus 2 times 3 minus root 5 plus 12, that's also acceptable. They're not testing your arithmetic. They're testing whether or not you understand what to do. If you simplify it wrong, you don't get the points, Rachel. So it's, you know, unless you're real confident or real OCD about it, then you might as well just leave it. Any other questions there on C or D? Yeah, correct, Darius. I mean, there's no reason to simplify them unless you just really want to. But it's only numeric values. So like f of 5 is not a numeric value until you turn it into 0. So Sean, I know you asked if these 4 questions are supposed to be done in 25 minutes. I know you just sent it to me, I guess it looks like, now that I see that. But apparently I'm going to answer it to everybody. No, there's, I think, 3 more parts to it. So we'll move on. Or at least 2 more. I think there's E and F, and there might be a G also. But yeah, if they only had you do those 4 in 25 minutes, that shouldn't take 25 minutes, I wouldn't think. So if we look here at part E, we've got now a new function, the function G, which is given by the integral from -2 to x of f of t. And we want to find the absolute maximum value of G on the interval from -2 to 5. So in order to find an absolute maximum, we have to find any places where there could be local maxima, and then we have to also check the endpoints since this is a closed interval. So anytime you're looking for absolute max or min, check the endpoints if it's a closed interval. So possibilities are x equals -2, x equals 5 to start with, and then any critical values of G. So G prime should be equal to just f of x, because the derivative of the integral from a constant to x of a function, according to the first part of the fundamental theorem of calculus, is just that function. So if G prime is f, that means that G prime equals 0 whenever f of x equals 0, which we should be able to see pretty easily here. There's -1, and there's a half, and there's also 5, but 5's already in our list over here. So then we need to determine between those values, this is true at x equals -1 and x equals +1/2, of those values, which one could be a max. So our derivative f goes from positive to the left of -1 to negative to the right of -1. So if we were to be making a sign chart, -1 and 1/2 on there, here we're positive, which means we're increasing, and here we're negative, which means we're decreasing. So this is a max, a local max, could be an absolute max. And from 1/2 on, it's positive, which means we are now increasing, which makes this one a min. So we don't really need to worry about x equals 1/2. The only other one that we're interested in is x equals -1. And so then we just need to figure out which of those three values is the largest when we plug them into G. So we should pretty quickly be able to evaluate here. G of -2 is just the integral from -2 to -2 of f of t dt, which is 0, right? Because the integral from a to a of any function is just 0. Then we'll do x equals -1 first, just because that comes along a little more quickly. If we were at 0 at -2, g of -1 should just be the integral from -2 to -1 of f of t dt. And so that integral is this positive value up here, which is 1/2 is the area of that triangle like we found before. It's 1/2 base times height, or 1/2 of 1 times 1. So x equals -1 should be positive 1/2. And then to figure out what g of 5 is, g of 5 is equal to the integral from -2 to 5 of f of x. And if we go back and look at part C, we had found the integral from -2 to 5 of f of x. The integral from -2 to 5 of f of x was 11 minus 9 pi over 4. And 11 minus 9 pi over 4, well, even if, let's say that pi was equal to 4, which we know that it's not, we'd end up with 11 minus 9 over here, which is 2, which is certainly greater than 0, and it's certainly greater than 1/2. Just to do a quick approximation there, we know that that's greater than 1/2. And so therefore, at x equals 5, we have our max of 11 minus 9 pi over 4. And since it says what is the absolute maximum value of g, the answer should be 11 minus 9 pi over 4. It doesn't ask, but we could say that that occurs at x equals 5. Sometimes it might not include, or it might ask you to include the actual value at where it occurs. Juliana, it asks for the absolute max, not all local max. So you need to test at x equals -1 to get the 1/2, but that should not be part of your answer. Molly, no, you don't need to write out the integral every time. You could just say, I think g of -1 equals 1/2, and that would be fine. Sean, the justification for your answer there of shading it in, that will show that it's clearly more than 1/2. But it doesn't show you why it is exactly 11 minus 9 pi over 4. That justification comes from finding each of the values at -2, 5, and -1. Juliana, I think I misread your question, Juliana, that we don't need to include x equals 1/2. And this will answer yours too, hopefully, Ada. You don't have to include the x equals 1/2 because we know that this is a minimum here because the derivative, which is f, is going from negative to positive, which means that it's going from decreasing to increasing, which makes it a minimum. And if it's a local minimum, it certainly can't be the absolute maximum on the graph. That's why you don't need to include x equals 1/2. Does that make sense, Juliana and Ada? Okay, let's see. I think Sean, your question is next here. The sine chart, yeah. So, and this will, before I go through the sine chart, I'll get to that, Sean. I'm going to answer Justin's question real quick. Why is G prime f of x? Because that'll help us with the sine chart. G prime is f of x because, yeah, let me give myself a new page here. So if we've got g of x is equal to the integral from -2 to x of f of t dt, when we take the derivative with respect to x of both sides of this, that tells us that g prime, or the derivative with respect to x of g, is equal to the derivative of the integral from a constant to x of a function. And the first part of the fundamental theorem of calculus says that the derivative of the integral from a constant to x of any function is just that function. So, Justin, does that make sense why g prime is equal to f now? Okay, and then so, Sean, since g prime is equal to f, to figure out the sine of g prime, we just look at the sine of f. And from -2 to -1, f is positive, right? It's, it's going from 1 to 0, but it's a positive number, so it's increasing. So g is increasing. And then from -1 to 1/2, right here, all of this, the values of f, or the values of g prime, are negative, so the function g is decreasing. And then from 1/2 to 5, the values of g prime, or the values of f, are all positive, and so g is increasing. Does that make sense, Sean? Okay. All right. Any other issues with that? Everybody feel okay about part E? All right. For part F, we're now looking for the limit as x approaches 1 of 10 to the x minus 3 f prime of x over f of x minus the inverse tangent of x. So first thing we'll do is we'll just plug in 1 and see what we get. 10 to the first power is 10 minus 3 times f prime of 1. And we'll figure out what f prime of 1 is in a second. And then over f of 1, which we'll figure out in a second, minus the inverse tangent of 1, which we should know is pi over 4. So f prime of 1 means what's the slope of f at 1. So the slope here, well, it's just a regular line. The slope of this line has a rise of 2 and a run of 1. So f prime of 1 is 2. We got a slope of 2. So we've got 10 minus 6 in our numerator. And our denominator, we've got f of 1, and f of 1, well, the y value at x equals 1 is 1. So that's 1 minus pi over 4, or 4 over 1 minus pi over 4, which is also acceptable. That's good enough. You don't need to simplify it any further than that. Generally, those ones come out to be indeterminate, and they make you take derivatives, but apparently not in this case. So there's your answer for part F. Any questions there on F? You guys can all still hear me all right?
Yes, we can hear you.
Okay, just making sure. Justin, yeah, they could potentially ask you to take a derivative of a function like that using L'Hopital's rule. I think we've done one or two in some of the other review sessions similar to that, but those pop up pretty often. And in the ones that I've seen that I've been doing this year, this is the first one that actually came out to be a numeric value. Sometimes they'll make them 0 over 0 where you have to take the derivatives. And sometimes they come out to be like, they'll have it come out to be like 7 over 0, where you would then say that the limit doesn't exist, in the hopes that somebody might think, oh, it's just supposed to be L'Hopital's rule and do L'Hopital's rule with it because they saw that the denominator was 0. But yeah, they might make you use L'Hopital's rule. Yeah, I mean, you've got the derivative formula sheet, so it shouldn't be too bad. I mean, you're going to be able to have whatever notes you want sitting in front of you. So, Melinda, no, you don't have to redo the work for finding G of 5 from part E. Just state what it is, and you could write from part, whatever part it was we got it from part C. Amy, no, the inverse tangent of 1 is pi over 4. Inverse tangent only operates from negative pi over 2 to pi over 2. So you're only able to get out values in the first or fourth quadrant when you take the inverse tangent of something. I might add, maybe I should add that in onto your review sheet. That's, technically a pre-cal thing, but most of you didn't take pre-cal. So inverse sine and inverse tangent, when you take the inverse sine or inverse tangent of something, you always get an angle in the first or the fourth quadrant. And if you take the inverse cosine of something, you always get something in the first or second quadrant. But I'll add that into the sheet and repost it sometime today, hopefully. Chun, the sheet is in the Google Drive. I sent a link to it. You were probably asleep. So, but I sent a link to it last night, and then I corrected a couple things and sent a new link maybe 30 minutes before we started today. All right, and part G is the last part of this 25-minute problem that they've assigned us here. Is we've now got still that g of x is the integral from -2 to x of f, and we want to know, is the rate of change in g increasing or decreasing at t equals 1? So the first thing we need to say is the rate of change of g, well, that's g prime, which is f. That's the rate of change of g. And if we want to know, is it increasing or decreasing, that means take the derivative of this to see if it's increasing or decreasing. So g double prime, the derivative of g prime, should be the same as f prime. So we are interested in, is f prime positive or negative at t equals 1? And at t equals 1, we'll say that f prime of 1 is 2, because that's the slope of f at t equals 1. That's greater than 0, and so we will say it is increasing. And this is your justification right there, and that's good enough for your justification. Any questions on part G? All of that in 25 minutes. You'll be fine. I don't think that it shouldn't take you more than 25. I mean, how long did it take us to do this? 1 minute. Well, we didn't finish in 25 minutes of truth, but I had to explain everything, each part of it 5 or 6 times. So Molly, if you just said increasing but didn't explain, it's hard to say if that's partial points or no points. It just sort of depends on how the points are assigned for this, and they didn't give me a scoring guide for this. They didn't give me the answers or the scoring guide for this problem. So I don't know how they would have assigned the points for this. They might give you 1 for saying increasing and 1 for saying or for giving your reason, but I can't say for sure. Natalie, we're using G double prime because the rate of change in G is what we're trying to figure out if it's increasing or decreasing. And so the rate of change of G is G prime. And we want to know is the question that it's asking us is basically is G prime increasing or decreasing? And to figure out if G prime is increasing or decreasing, we need to figure out what is the derivative of G. And so the derivative, what is the derivative of G prime? And what is the derivative of G prime? The derivative of G prime is G double prime, which is the derivative of F or F prime. Does that make sense, Natalie? Okay. You saw, no, you don't need to use the second derivative test for this. You do not need to. Ben, there's on the actual test, there's going to be this, something similar to this you'll get 25 minutes for, and something similar to like what we did the first problem today or any of the other free responses we've done, and those are 15 minutes each. They give you 5 minutes to upload your responses, so that's why it's 30 and 20 minutes, but it's really only 25 to work and 5 to upload, and then 15 to work and 5 to upload. Any other questions there on part G or any of it? Chen, it's up to you. I mean, if you've gone in and done the demo, you'll know how easy or difficult it is to type it in on their system, and whether or not you feel comfortable doing that is up to you. If I were the one taking the test, I'd probably just write it all out and take a picture of it, or scan it or whatever and submit it that way. But that's just me. That's up to you guys' own choice. That's why I sent you guys that demo to test it out and see what you think will work best for you. So. The truth, I honestly don't know. They have given me no direction about how they're scoring it, other than it's not going to be more difficult to get each grade. I mean, they've told me nothing more really than what they've told you. I mean, normally if you're getting around 70 to 75% correct on the test, that's around the cutoff for a 5. I would imagine that that's still the case this year. But I really, it's hard for me to speculate about it. Natalie, I'm not sure if it's going to let you, I don't think it's going to let you exit out of the browser to take a picture. It might, I don't know for sure. That's why I say go in and do it on the demo. If it works in the demo, it should work during the test. So test it out and see what works for you. Tanya, could I take the derivative of F prime with the info given? Could I take the derivative of F prime? So could I find F double prime? Is that what you're asking, Tanya? Yeah, you could find F double prime because we know that F prime is a constant. F prime is just equal to, at least from 0 to 2, f prime is equal to 2. And so the derivative of f prime, f double prime is just the derivative of 2, which would be 0. Yeah, Sean, if you scroll back through on the remind messages I've sent out, there is a link to the demo. Any other questions on these problems that we've done?